Hi guys, it's me Manelisi again, and today I'm going to be doing geography, and we are going to be looking at low pressure cells. Remember, we only have three low pressure cells to deal with, which is your coastal low, your mid-latitude cyclone and tropical cyclone, and an extra one, which is your thermal low. So now today we are going to be looking at your mid-latitude cyclone. Okay, so we said we are going to be looking at your tropical cyclones, but I just want to remind you of the other low pressure cells, which are your coastal low, which runs along the coast. It runs along the coast, and your thermal low. Your thermal low forms when a Kalahari high pressure is weak, right? Then a thermal low forms over land. Now we are going to be looking at where a mid-latitude forms. That's the first point, where a mid-latitude forms. So the first thing we know is that a mid-latitude forms at the front, right? Now we have to know which front is that one. So it forms at the polar front, right? Now remember, we will be talking about your latitude and longitude. So on which line of latitude? So mid-latitude cyclones form between 30 degrees to 60 degrees north or south, right? So that's where mid-latitude cyclones form. They form on the westerlies line. They are driven by your westerlies. Now you also have to know that mid-latitudes can only form when cold air from the polar or poles meets warm air from the equator, right? Warm air from the equator. Now this is how it will look. So this is your front. On either sides of your front we have your cold air and your warm air, right? So these two meet at this front. Where they meet, they form a front, which we call that front your polar front. Now we are going to look at other names for a mid-latitude cyclone. You may find that they called it a temperate cyclone, a frontal depression, or an extra tropical cyclone, right? So those are the three other names for a mid-latitude cyclone, or your extra tropical cyclone. Now every time when you are dealing with your low pressure cells and high pressure cells, you have to know the areas of formation. You have to also know the conditions necessary for formations, which is what we are going to be looking at now. But first, I'd like us to start with the characteristics of a mid-latitude cyclone. The characteristics, I'll just put them as short as possible and explain. Now, the first characteristics, we know that mid-latitude cyclones only form at between 30 degrees and 60 degrees north or south. That's the first one. So this is how they will look on your world map. So we know at the equator is 0 degrees, then we have your 30 degrees, then we have your 60 degrees, then we have your 90 degrees at the polar. Now look at this. At the equator, we already know it's a what? Low pressure. And at 30, it's your high pressure. 60, it's your low pressure. So they form between these two pressure cells, 30 and 60. This high pressure cell, which is your subtropical, and your subpolar low pressure cell. Now they are driven by your, remember, from 0 to 30 we have your trade winds, which are your tropical easterlies, right? Tropical easterlies. Now we also have your westerlies, right? Driven by your westerly winds, right? So now we know that the other characteristic of this cyclone is that it moves what? Eastwards. Moves eastwards. Now look at this. So this will be your now we shall eat, right? This is your compass. Remember we said they are driven by your westerlies, right? That's why they move from the west to the southeast, right? Now if a cyclone forms around here, these winds will push it that way. So that's why we say the direction in which they move is your eastwards. They move eastwards. Now the other characteristic has fronts. So mid-latitude cyclones have fronts, a cold front and a warm front, right? Remember, your cold front is represented by triangles, but your warm front is represented by semi or half circles, right? Now in front of your cold front we have cumulonimbus clouds forming, right? Remember, there is a steep gradient. There is a steep gradient on your cold front, so there is a high condensation. High condensation, and high condensation leads to rain formation and thunderstorms. Now remember, this is a low pressure, so it will look something like that. And remember, South Africa is only affected by your cold front. South Africa is only affected by your cold front because your warm front is further south from South Africa. It's further south. Okay. Now the other characteristic has a large diameter. Large diameter. That means mid-latitude cyclones are huge, right? By diameter they mean this. Now remember, your cyclones or pressure cells are represented by your isobars, right? So these lines are your isobars, which join areas of same pressure. Now that means a mid-latitude would have formed at that point, right? Then we call that a low pressure. So they have a large diameter. Your diameter is from your circumference to your circumference. So that area there is large. Now to the next characteristic, which is they are steered. We've already talked about this one, by westerlies. So this is what we were talking about, that they are being pushed by these winds moving from the west to the east, right? Which pushes a mid-latitude cyclone eastwards. Now the last one, important one too, they only affect South Africa in winter. Only in winter. Remember, we said only the cold front affects South Africa, and the cold front only affects South Africa in what? In winter. So that's important to remember. Always remember that mid-latitude cyclones only affect South Africa in winter. Now, we move from your characteristics. Now we are going to be talking about the conditions necessary for formation. The conditions necessary for formations. Remember, when you talk about condition, we talk about your humidity, we talk about your temperature, we talk about your evaporations. So those are all conditions. So we are going to be looking at conditions necessary for a formation of mid-latitude cyclone. So firstly, there has to be frictional drag. Frictional drag. So this frictional drag can either be caused by the two air masses as they collide or move parallel to each other. So there can be a frictional drag between these two winds. So remember, why do we need the frictional drag? Remember, they form at a front. For this front to start forming a mid-latitude, it has to have a kink or wave. So this frictional drag will cause the formation of a what? A wave. So we'll have something like that. As time goes by, this warm air will dive deeper into the cold front till this becomes a matured cyclone. Now, so that's why we need frictional drag. Frictional drag can also happen because of your temperature differences between your air masses, or when winds move from ocean or water surfaces to land. So that could cause your frictional drag. That's why cyclones or low pressure cells always become weaker on land. Now your next condition, which is your air masses must move parallel to each other. So I've already explained why they must move parallel to each other. This difference in temperature and the parallel movement of these airs will cause a wave along that front. Now our last one, I'll just write parallel to each other, right? Then in brackets, air masses, right? Now the last one is fronts begin to form, air converges to the center of the low front. So now, since there is a wave that has formed, right? It's as I said that this front will form and that front will form. Remember, this was just a wave. Now it will look something like this, right? Then your fronts have formed. So after your fronts have formed, we call this a what? Matured mid-latitude cyclone. A matured cyclone, right? So now it qualifies as a what? Cyclone. Okay, now we are going to look at the stages of formation. Stages for formation, right? The stages for formation. How a mid-latitude forms till it's a matured cyclone and till it dissipates or it reaches its occlusion stage. Now the first stage is your initial stage. Now I'm going to draw how your initial stage looks like, right? So your initial stage will look like something like this. Remember, on your initial stage we still have that normal polar front, right? This is your front. On the other side of your front we have cold air from the polar poles, and then on the other side we have your warm air, right? Now, all this on a map will look like something like this. Now your 30 degrees, your 60 degrees, and your 90 degrees. And remember, you find your polar front where? There. So that's where you will see your warm westerlies and your cold polar easterlies converge. So they form a front along that line. That front, as we see it, is this one. It's your polar front. Now, the cold air mass and the warm air mass move parallel to each other. Right? They move parallel to each other. Remember, we said that's a condition necessary for formation of a mid-latitude cyclone. The air masses must move parallel to each other. Now, your wave stage, right? Your wave stage will look something like this. It's still your polar front, but frictional drag took place, right? So now frictional drag takes place and this warm air starts moving that direction. That cold air starts moving that side. So this frictional drag causes warm air to become uplifted. So it will look something like this. Cold air undercuts or goes underneath the warm air, causing the warm air to rise. Remember, your cold air is dense. Your warm air is light, right? So it's easier lifted. So this is heavy air and that is light air. So that's why this air will go underneath and undercut. Then this one will start rising. So this rising effect will start the formation of clouds. Remember, when air rises and reaches condensation level, clouds start to form. So that's what happens in your wave stage. Fronts start to form, but they are not yet really formed. As we can see, this will be your cold front and that there will be your warm front, but they are not yet matured. Now that's your middle, the center of your cyclone, right? Now we move to the next stage, which is obviously your mature stage, right? Now on your mature stage will look something like this, right? You have your fronts which have fully formed. You have your low pressure cell now, which has also fully formed. Now remember, this is important. You have to know that behind your cold air is your cold sector. So this whole part is your cold sector, and then behind your warm front we have your warm sector. So this warm air is driven by your cold front. This cold air is driven by your cold front, and this one by your warm front. So the rotation of this cyclone goes that way, right? So I'll just draw that rotation this side, then we discuss that rotation. So that rotation is clockwise. So this is also a characteristic of a low pressure cell or a mid-latitude cyclone. It rotates clockwise in the southern hemisphere and anti-clockwise, right, in the northern hemisphere. So that's another characteristic of a mid-latitude cyclone. So this only forms when this wave depends, right? That's the first thing that will happen. This wave will depend as more cold air causes warm air to rise. And now your cold front and warm front are fully developed, right? Which is what we see then. We have your cold front and your warm front. Now warm air starts to move on your steep gradient. Remember, we said on the cold front there is a steep gradient. So that steep gradient looks something like this, right? Then we have a gentle gradient on your warm front, right? So warm air is flowing on this part, right? So it starts rising on the steep gradient of the cold front, which is this one, right? That's your cold front. So it starts rising on that gradient and forming what? Cumulonimbus clouds. Remember, we said when more warm air rises, it condenses and forms clouds which will cause rain or thunderstorms. So now cumulonimbus clouds are associated with a lot of rain and thunderstorms. So cumulonimbus clouds starts forming in front of the cold front. So I guess we know now why on the cold front, because warm air rises on the steep gradient of a cold front. Now warm air moves up the gentle gradient of a warm front and forms stratus clouds, which are smaller clouds. Now these ones are not associated with that much of rain, but they also bring rain. Remember, this is a low pressure cell, so it's associated with unstable weather conditions, right? Unstable weather conditions. Now obviously after you mature, you now reach your granny stages. Now are an adult, now you are dissipating, right? So that stage we call it your occlusion stage, right? The last stage of a mid-latitude cyclone, where it starts to dissipate and lose power. Now what happens in this stage? This stage will look something like that. So this is also your warm front, that's your cold front. But now we have an occlusion front. What is an occlusion front? So if an occlusion front is when cold air catches up with your warm air and start to zip from the apex. So what is your apex? So your apex is this part of your mid-latitude cyclone, right? That first part of your mid-latitude cyclone is your apex. So these cyclones start to combine to form an occlusion front. So an occlusion front is an combination of your cold and warm front, right? So that's your occlusion front. Let me just label it there. Occlusion front, right? Then you have your cold front and warm front. And then on that occlusion stage, cold air or cold front occlusion may form. So this part is very important. I need you to listen. When a cold front occlusion forms, that means the cold front touches the ground and starts to uplift your warm front, your warm front. So your warm front will be undercut. So this was supposed to be your warm front, but now it has been lifted by your cold front. Why? Because the air behind the cold front is cold, but the air behind your cold front is colder than the air behind your warm front. So that means this air is a little bit warm. So that causes this front to rise. Remember, warm air is associated with rising since it's lighter than cold air. So if this air is colder, that means it will start to descend and sink, right? Which will touch the ground. So this is your ground. Now since this air behind the warm front is a little bit cooler, it will start rising, causing this warm front to undercut, right? So that's why we don't have your warm front there. Now we are going to look at your warm front occlusion. So your warm front occlusion will look something like this. Now your warm front is touching the ground and your cold front is uplifted, right? Now why is this so? The air behind your warm front is colder than the air behind your cold front. Same theory as here. That means this air is lighter than the air behind your warm front, which causes this cold front to start uplifting, right? To be uplifted and undercut. So this was supposed to be your cold front, but now it has been caused to uplift above your warm front. So that was all for your geography. So now we were looking at your mid-latitude cyclones, one of your low pressure cells obviously. Now remember, on your cold front and warm front, you have to know the weather conditions associated with those fronts, right? And you also have to be able to characterize conditions according to whether the cyclone has passed, or the cyclone is on that area, or the cyclone is coming towards that area. So you have to know the conditions associated with those three. You also have to know that mid-latitude cyclones can occur in families from 2 to 5, right? So you can have about 5 cyclones on a synoptic weather map at the same time, occurring at the same time but at different stages. But the oldest one would have reached your occlusion stage or your mature stage, and the youngest one would still be at your mature stage or your initial stage. So it depends on those characteristics you are seeing on that map. Now we have a YouTube channel called Tutoring Wisdom and Lwazi Films, so check us there. If you need anything, you can comment and ask us any questions, then we'll look at those topics and send those videos to you guys. So you can search for us at Tutoring Wisdom or Lwazi Films. Please comment, like, subscribe and share. Thank you very much. You can also contact us at 076 587 5041, and then we'll add you to a group called Tutoring Wisdom. If it's not Tutoring Wisdom, it's not us. Thank you.